question 1A. The question is Zaliha invests Rm 12,300 ringgit in an account that earns 13.5% interest compounded semi-annually. How long it take for her investment to double in value? So in this question, the formula that is being used is S equal to P in bracket 1 plus I the power of N. And now we know that the P is Rm 12,300 ringgit and the K is 0.135. The M is semi-annually, which is 2, and I is 0.135 divided to 2, and the N is 2 multiplied to T. We substitute the numbers and we get 2 in bracket 12,300 equals to 12,300 in bracket 1 plus 0.135 divided to 2 in the power of 2T. Then the first thing first you need to do was in the bracket, which is the 1 plus 0.135 divided to 2. And then we get the answer is 1.0675. And then we do the 1 on the other side. And then we cancel the 12,300 because it's the same. And then we get the answer 1.0675 to the power of 2 times t. And then we are going to use the logarithm rules in this question. So we insert the log 2 equals to log in bracket 1.0675 the power of 2 times t. Then we are going to move the power of 2 times t to the in front of the log 1.0675. There we have log 2 equals to times t log 1.0675. And then we are going to move it again. We move the t to the front because we are going to find the year. So we have t equals to log 2 divided to 2 log 1.0675. We are going to put it in the calculator to calculate it. So we got log 2 as 0.31029995 divided to 2 in bracket 0.028367883. And then we are going to multiply the numbers in the bracket first. So we will get 0.056735766. And then we are going to divide these two numbers. So we got here are 5.3 years. So the answer is it takes 5.3 years for Zaliha's investment to double in value. So now I'm going to explain the question 1B, which is Bazila invests Rm 20,000 in an account that earns 7.5% interest compounded quarterly. We are going to find the amount Bazila will receive at the end of 5 years, which is the question 1. And then the question 2, after 5 years, the bank increased the interest rate to 8% compounded quarterly. Find the amount in Bazila's account at the end of 7 years of investment. For this question, we are going to use the same formula we have done in the past question, which is S equal to P in bracket 1 plus I the power of N. And then we have P is Rm 2,000 ringgit, and then K 0.075, and then M, which is we have compounded quarterly, we get 4, and then T, which is 5 years, and then I 0.075 divided to 4. And then we got the N is 4 multiplied to 5, we got 20. Now we need to substitute these numbers. In the question 1, we got S equal to 2,000 in bracket 1 plus 0.075 divided to 4 to the power of 20. And then we got the answer for the first question is 28,998 ringgit 99 cents. And then for the question 2, we are going to use the answer from the first question as the P1. We are going to find the amount in Bazila's account at the end of the 7 years of investment. We substitute the numbers. S2 equals to 28,998 ringgit 96 cents in bracket 1 plus 0.08 divided to 4 to the power of 8. And then we calculated the answer, 33,976 ringgit 19 cents. This is the amount of money in Basila's account at the end of 7 years of investment. And that's all from me. Thank you.
Hello everyone, my name is Nadia and I'll be answering part A, question 2, A and B. Okay, let's start with the first one. 5 years ago, Ahmad deposited ringgit Malaysian 15,000 into an account that earns 5% interest compounded monthly. Today, he plans to add ringgit Malaysian Y to the account. Find the value of Y if he wants to have ringgit Malaysian 45,000 in the account 10 years from today. Okay, for this question, I need to find how much Y Ahmad has to add for today. I'll calculate the future value of the old deposit using the formula S equal to P, open bracket, 1 plus I, close bracket, and the power of N, which is 15,000 ringgit. The interest rate 5% compounded monthly, so the monthly rate is 0.05 divided by 12. The time is 5 years, which is 5 times 12 equals 60 months. So, the future value is 15,000 multiplied by open bracket 1 plus 0.05 over 12 close bracket to the power of 60. This gives me 19,250 ringgit and 38 cents. For step 2, now I calculate the future value of Y. Y will grow for 10 years. 10 years times 12 equals 120 months. So the expression is Y multiplied by open bracket 1 plus 0.05 over 12 close bracket to the power of 120. Now step 3, I form the total equation. The future value of the old money plus the future value of Y must equal 45,000. So I write 19,250 ringgit and 38 cents plus Y times the growth factor equals 45,000. Therefore, I solve for Y. I move the 19,250 ringgit to the other side and divide. The answer come out to approximately Y equals 50,634 ringgit and 26 cents. So Ahmad needs to deposit about 15,634 ringgit for today. Let's move on to the next question. Zaleha invests ringgit Malaysian 7,000 at an interest rate of 6.4% compounded monthly for the first 6 years and 6% compounded every 4 months for the next 4 years. Find the maturity value and the total interest earned at the end of the investment. For this question, there are 2 different interest periods. Step 1, the first 6 years are at 6.4% compounded monthly. Monthly means M equals 12, so the monthly rate is 0.064 divided by 12. The number of months is 6 times 12 equals 72. So I calculate 7,000 multiplied by open bracket 1 plus the monthly rate close bracket to the power of 72, which I used the previous formula from the question before. This gives 10,266 ringgit and 54 cents. Step 2. Now, the compounding change. The next 4 years use 6% interest compounded every 4 months. Every 4 months means 3 times a year, so the rate per period is 0.06 divided by 3, which equals 0.02. The number of periods is 4 years times the 3 equals 12. So I take the previous amount and multiply it by open bracket 1.0 to close bracket to the point of 12, to the power of 12. This gives 13,020 ringgit and 47 cents. Step 3. This is the maturity value. To get the total interest earned, I subtract the original 7,000 ringgit So 13,020 ringgit and 47 cent minus 7,000 equals to 5,717 ringgit and 36 cent. So the majority value is 12,717 ringgit and 36 cent. And the total interest earned is 6,020 ringgit and 47 cents. That's all from me. Thank you.
Hello, my name is ADRIANA. My student number is 2025135025. Today I'm going to discuss about my question, part B, question number 1, which is the content of the topic annuity. So as we look at the question, it says that Kenanga Bank offers a personal loan of Rm 250,000 ringgit with an interest rate of 4.8% compounded monthly. The customer must pay back the loan through monthly payment for 25 years. So the first question with 5 marks is find the monthly payment. As we can see, the present value here is 250,000 ringgit and the annual interest rate is 4.8%, or we can say 0.048. The time in years is 25 years and the amount of compound is monthly, which is, if it's monthly, is 12. Firstly, we need to find the I, which is interest rate per period, and then the I is equals R over M. R is nominal annual interest rate and M is how many times we compound. In this case, we can see our I is 0.048 over 12, which is equals 0.004. Our N is M times with T, which is 12 equals with 25 years, equals 300 payments that is needed to be settled. So firstly, to find the monthly payment, we need to use the formula where we find the present value of an ordinary annuity, which is A equals R, 1 minus, in a bracket, 1 plus I, close the bracket, with negative square root over I. But to rearrange the problem of the regular payment, we need to find the R instead of A. So it equals to R equals A I over 1 minus, in bracket, 1 plus I, closing the bracket, negative square root. So we need to put the number inside the formula. R equals 215,000 and then 0.004 over 1 minus, in a bracket, 1 plus 0.004, closing the bracket, minus square root 300. And then when we solve it, we got 250,000, 0.004 over 1 minus, in a bracket, 1.004, closing the bracket, negative square root 300. After that, we calculate the value of the numbers inside the bracket and also the square root beside the number inside the bracket. So it equals to 0.3010787. And then after we just minus our calculation with 1, we are going to do another calculation, which is 250,000, 0.004 over 0.6989213, where we can calculate the final value of R, 215,000 times with 0.005723049, which is resulting to R equals 1,413 ringgit 76 cents. So as we can see, the monthly payment, which is the R, is Rm 1,430 ringgit 76 cents. Immediately for the question B, it asks us, after the 288th payment, the customer decided to settle the balance of the loan. Find the amount to be paid, which has 5 marks. So as we can see here, the amount, which is the balance, we call it, or present value remaining, is going to be labeled B, and then number of remaining payment is going to be N minus with K. So we're just going to minus N with K. N is 300 minus with 288 equals 12. So we can see here that the number of remaining payment are 12 times. The formula of outstanding balance is B mini k equals R 1 minus in the bracket of 1 plus I closing the bracket negative square root in the bracket n minus k closing the bracket over I. As we can see here, the k is 288 times and the r is 1413.76 and our I is 0.004. Our square roots are negative 12. So we can, when we substitute the formula, we got B 288 equals 1413.76. 1 minus in the bracket 1 plus 0.004 closing the bracket negative square root 12 over 0.004. So when we calculate the value of 1 in the bracket, which is 1.004 minus square root 12, we got 0.9535805. So when we complete the calculation, the one that is minus 1 minus the balance, we got B 288 equals 1430.76 and 0.046495 over 0.004. And when we calculate everything, we got B 288 equals 16,590 ringgit 23 cents. So the amount of balance they need to pay after the 288 payment is RM 16,519 ringgit 23 cents. So that's all for my explanation today. Thank you so much.
Question part B, question number 2. Alicia borrowed 25,000 to buy a sofa set. She agreed to settle the loan in 24 monthly payments at 4.8% compounded monthly. A. Find the monthly payment and the total interest charged. 6 marks. B. If she fails to pay the first 5 monthly payments, find the amount that she must pay on the 6th payment to settle the outstanding areas. Equals to 4 marks. Solution for question B 2A. Formula for monthly payment on a loan. P times R, 1 plus R to the power of n, 1 plus R to the power of n minus 1. To calculate the monthly interest rate, annual rate equals to 4.8% equals to 0.048. Monthly rate equals to 0.048 divided by 12 equals to 0.004. To calculate the monthly payment, 25,000, 0.004, 1 plus 0.004 to the power of 24 divided by 1 plus 0.004 to the power of 24 minus 1. Calculate 1 plus 0.004 to the power of 24 equals to 1.004 to the power of 24 equals to 1.1000486. 25,000, 0.004 times 1.1000486 divided by 1.1000486 minus by 1 equals to 25,000, 0.004401944 divided by 0.1000486. 25,000 times with 0.04379 equals to 1,049.75. Total payment and interest. Total paid is equals to 1,094.75 cents times with 24 months, which is equals to 26,274. And the interest charge, we must subtract the total of the payment and with the principal. 26,274 minus with 25,000. Solution for question B to B, we are going to use the formula of S equals to R 1 plus I to the power of n minus with 1 divided by I equals to 1094.75 in the bracket 1 plus 0.004 to the power of 5 minus with 1 divided by 0.004. Calculate first the 1 plus 0.004 to the power of 5, which is equals to 1.0202. A equals to 1094.75, 1.0202 minus 1 divided by 0.004, which is equals to 1094.75 times with 5.05, which is equals to 5,528.49. Thus, add the 6th payment to settle the arrears. which will be 1,094.75 cents plus with 5,528.49 cents, which is equal to 6,623.24 cents.